Okay, so in this video, what we're going to do is show how more and more terms of a Taylor series approximate that function better and better. So again, this is going to feel very similar to what we did for power series, showing that more terms in a Taylor series better approximates the function. And for this particular example, we're going to look at the function sine of x. And remember sine's Taylor series or Maclaurin series, a Taylor series centered at 0, is equal to the infinite series from n equals 0 to infinity of minus n x to the 2n plus 1 all over 2n plus 1 factorial. So let's just remember what sine looks like. So our sine function, this is sine between about, I think, negative pi and 3 pi. And what we're going to do is basically just tack on more and more terms. So at first, we're going to consider, well, what does sine look like if we just took the first term of its Taylor series? So we're going to approximate sine by truncated Taylor series polynomials. So the first term of sine, if you remember, is just x. So if we just have the first term of sine there, what's coming out in red is just if we have that particular approximation, sine being equal to x, being evaluated between x values of minus pi and about 3 pi. Or 4 pi, rather. And what we see as well, very close to the x equals 0 region, this approximation looks like it does pretty good. But the further away we move from x equals 0, the point in which our Taylor series is centered, the worse the approximation does. Okay, let's add on the next term of the series, which you might remember to be a minus x cubed over 3 factorial, the second term of our sine series. So let's see what that approximation looks like. So just two terms of the sine series now, the x and the minus x cubed over 3 factorial. We're getting pretty good agreement right near x equals 0 again. We're starting to see some of this curvy business. It's hugging the side, the actual sine curve a little better, that red line to the black line, but it's not doing quite that well really far away from 0. So let's tack on another term. The next term of sine series is x to the 5th all over 5 factorial. So tacking on the next term, we are now capturing basically the first maximum and the first minimum of sine pretty well. But again, going further outside of that region, centered at 0, our approximation gets worse and worse. So let's tack on yet another term, x to the 7 over 7 factorial. And well, just using the first 4 terms, our approximation is looking pretty good, almost between negative pi to pi. And this is to say, if we keep adding on more and more terms of this Taylor series, really approximating sine by just a truncated Taylor series, or just by sine by just polynomial terms alone, using just the first 5 terms, maybe the first 6 terms, we're starting to see pretty good agreement between our Taylor series being truncated, or a truncated version or finite polynomial representation of sine, and the actual value of sine itself. The more terms of sine that we add in its Taylor series, the better approximation gets. And for this value, for the values of x between about minus pi to 4 pi, just using about 19 terms of this Taylor series is almost all we need to get pretty good agreement in this range of x values. But again, the further away from x equals 0 that we move, because again, that's where we're centering this particular Maclaurin series, the worse our approximation will get.